in the last lecture we have studied what are the renewable energy sources, what is the need of energy, and different types of conventional sources, whether these are in the form of coal, maybe petroleum or natural gas, along with the nuclear energy. And in today's lecture we are going to see non-renewable energy sources. But before moving to that, we will see what is the alternative or alternate energy sources. Okay. So conventional sources of energy like coal, natural oil, gas are non-renewable, and their use is invariably associated with problems of environmental pollution. So that's why there is a need to move on alternate energy resources. So hydroelectric power generation has its own drawback, okay, that it is occupying large land and polluting, or it is harming the water resources. Large scale use of wood, it is an important source of energy, but we know that leads to a deforestation. Indian villages lead to deforestation. Okay, so non-conventional sources provide energy in a decentralized manner to small and remote areas. Okay, and if even we try that we are trying to build or use these resources on a larger extent. So large scale of non-conventional energy sources reduces the burden from conventional energy resources and system, and therefore it will help in enlarging their lifespan. So there are some non-conventional energy sources. That means even though we are using non-conventional energy sources, that means those who are not get depleted or reduced as we consume, or the rate of consumption is not proportional to the rate of depletion. Okay, but still that means those are non-conventional or non-renewable resources. If we put a pressure or we are exploiting them also, for that or to reach, or these are not available for even a particular area, okay, or the that energy resource cannot be used properly in a particular region because of the environmental conditions or the temperature. So that there is a need to move on alternate energy sources. Okay, so first we will see what are non-renewable energy sources, what are renewable energy sources and non-conventional energy sources. Okay, the first is, you see, the renewable energy sources capture their energy from existing flows of energy from ongoing natural processes such as sunshine, wind, wave power, flowing water, that is hydropower, and biological processes such as anaerobic digestion and geothermal heat flow. Okay, so that means the whatever the factors or the resources are available in the nature and which can be replenished or in the unlimited form. In 2004, renewable energy supplied around 7% of the world's energy consumption. The renewable sector has been growing significantly since the last year of the 20th century, and in 2005 the total new investment was estimated to have been a 38 billion US dollars. So it was in a 2005. Of course, there may be a 10 to 20% increase in the investment right now in a 2020. Okay, the Germany and China lead the investment of the about 7 billion US dollars each, and followed by United States, Spain, Japan and India. Okay, so first we will see what is solar energy. So solar energy source refers to the energy that we are getting directly from the sunlight. Okay, so solar energy can be applied in many ways, including to generate electricity, that is by using photovoltaic solar cells, to generate electricity using concentrated solar power, to generate electricity by heating trapped air which rotate turbines in solar updraft tower. Okay, now electricity by using solar photovoltaic cell, that is directly the energy is transformed or that converted into another form of energy, or that directly used at that time. Now using concentrated solar power means we are transferring or storing energy in the battery, and that we can use it afterwards. So the heat which is trapped by air can be used to rotate turbines, okay, to generate electricity or energy. The heat buildings directly carefully or the to heat buildings, careful positioning of windows and use of brises soleil, that is a small portion of the window. By opening and closing we can maximize or minimize the flow of air, okay, or inflow of air. So maximize inflow of light at the times in light at times it is most needed, okay. So it is for the light, but along with that the air is also coming. So heating the building while preventing the overheating during midday and summer, okay. The heat food to heat foodstuff through solar ovens, that is the most commonly used. To heat water for domestic consumption and heating using rooftop solar panels, okay. Nowadays this is more common in most of the countries, even in India. So to heat cool air through the use of solar chimneys, okay. Now solar energy use worldwide during 2005 approximately 93.4 gigawatt. However, the available resources are 3.8 hectajoule per year, okay. So that is 10 raised to 24 joule, okay. Now only small fraction of available resources are sufficient to entirely replace fossil fuels and nuclear power as an energy sources. However, it is likely that at least biodiesel will always be used in a certain types of transport, okay. So sometimes it can say it is sufficient or it is good to use this fossil fuel and nuclear power, but as we know that we cannot rely totally even on the non-renewable sources and renewable sources. So all these are substitutes of each other. So Portugal has opened the world's most powerful solar planet, that is the 11 megawatt solar power plant comprising 52,000 photovoltaic modules. It is based on southern Portugal, which is one of the sunniest place in the Europe, okay, as you can observe in the picture. So these are the photovoltaic cells. So even in the picture you can see it is spreaded over a large area, okay, and it is considered as the world's or the biggest solar plant, okay, or the solar power plant. Obviously sun does not provide constant energy to any spot on the earth, so its uninterrupted use requires a means for energy storage, okay, that is typically accomplished by battery storage. However, battery storage implies energy losses, okay, as we know that. So somehow home owners use a grid connected solar system that feeds energy to the grid during the day, draws energy from the grid at night, and this way no energy is expended for the storage, okay. So advantage of solar energy sources include the inexhaustible supply of energy, zero emission of carbon, and resulting no greenhouse gas emission and no air pollution. That means no rise in temperature and no pollution. So what are the technologies are used in the solar energy, or what is the use of solar energy for the human beings, or how we have used in different by using different techniques, okay. So application includes water heating, drying, space heating, distillation, and power generation. So first we will see that is solar photovoltaic cell. So these are the solar photovoltaic cell, okay, which are used to generate energy. Okay. So, this kind of panels or the cells you must have observed on the terrace, where the solar energy is used for the generation of maybe in the geyser, to that means to uh, can change the temperature of water. Along with that, somewhere in the gardens, okay, to generate electricity. So, in that region you must have observed this type of cells. So, it is a technology which is used to that directly converts radiation from the sun into electricity based on physical process that requires no moving parts. Okay. So, once you installed, okay, there is a low maintenance, that means you just have to clean the surface if there is a dirt, and no big machineries or the any kind of things required for the solar photovoltaic cells. Okay. So, SPV is a proven technology. So, it is possible to generate about 120 watts of electricity from 10 square feet area of SPV panel or on a sunny day. Okay. So, it is we can say reliable on different scales application, that is for suppose lighting, that is street, residence, public space, for running or operating electrochemical equipments. Okay, that means those are small equipments can run on this solar energy. There is radio energy and another system, TV, video players, fans, pump sets to supply drinking or irrigation water. Okay. Supplying electrical power to operate poultry incubator, rice mills, telecommunication equipments in remote area. Charge NICD batteries for use in torches, radios and soon. Okay, so NICD is a organization or the where the bank data is stored. So, all the nationalized bank, the data is saved, that is a national industrial corridor development, okay, corporation limited. It is at the New Delhi. Now, the solar photovoltaic module, okay, that provides an independent reliable power source at the point of use. So, it is making suitable for remote or inaccessible places such as even hills, okay, or mountains. The majority of the population which is living in dispersed community in rural area is away from main power grid could be supplied with electricity that is without difficulty. Okay, that means we can store it and provide it at a different region. So, environmental and efficiency implication, that the SPV system could provide national economic benefit as it would reduce reliance on imported fossil fuels. Okay. So, that means we cannot the reliance or the we won't rely on fossil fuels anymore if we consume or we try to generate more energy by SPV. Okay. Also, it is economically benefited. Okay. So, SPV are commercial economically valuable, taking into consideration high reliability of SPV. Many small scale applications can be more economically powered by this system and then with diesel or other small power systems. That means if we use this SPV, okay, these are economically viable, or we can say that is a price may change according to this photovoltaic cells. Okay. Now, this is not only environmentally friendly, but the one more thing is the farmers who are constructing that the in India also, or in the Maharashtra, that MSCB is giving a scheme, or it is providing a scheme that the farmers or the even the house owner, those who built this photovoltaic cells on their terrace or the above the region where of the house, then the energy will be generated in the form of electricity, and the house owner or the farmer will get energy free for the lifetime. So this is economically valuable, or we can say it is a good option for the farmers. So taking that is for the small scale application or the small startups, okay, for them also it is good. That is the though the investment for the one time, but it is giving your return for longer period of time. So SPV systems are environmental friendly. Their use protects the ecology and environment from degradation through the conservation of forest, reduction in the emission of harmful gases. An SPV system is carbon dioxide free and clean energy converter. Okay. So it is environment friendly, that means a greenhouse gas emission is very low, pollution free, that means there is no impact on the health. Along with that, there is a less emission on the, or the less impacts on the human beings. Okay. So another use which is in the form of solar lantern. Okay, that means portable lighting device, that the energy which is stored, that the photovoltaic cell which is the smaller is used in the this lantern, that is stored and can be used as per our requirement. So it can supply few hours of bright light a day, okay, without using a conventional fuels or AC, that is main power grid of power connection. The lantern can be used in remote areas without electricity. The solar lantern is ideal for campers, researchers, remote area, classroom, and even rural park offices, and military and that is police use. Okay. So these are just a name of models, that is the Solant 7 model. It is used mostly to generate energy. Now another use is for cooking. So as we know, there is a that is a box type solar cooker which is used. Okay. So the solar radiations, or there's a rays fall on the plane mirror, and that gets reflected, and by the heat energy the food gets cooked. Okay. The another use is in the form of solar for that is for the solar drying. Okay. So this is the any food or maybe agriculture product with a high moisture content is easily attacked by insect and can be that rots quickly because of the moisture content. So to guard against such possibilities and to prevent food for longer period time, okay, for longer periods, the food needs to be dried. So the traditional method of drying is to spread the food openly in the sun. So this is the drying method. The food often contaminated by dust and bird. Okay. So as per a percentage is lost or damaged due to insects or bird. So one of the good option for this is solar dryer. So solar dryer, as you can observe, it is an enclosed unit. Okay. So the food is safe from the damages, that is from birds and insects. So food is dried using solar thermal energy. That is a passive system of heating is used only on solar and wind. Okay. And the application is done for this drying purpose. So it the solar dryers can be made in different sizes, as you can observe in the picture, and the shape is also different. So depending on the domestic use or commercial use. So it can be made of locally available materials in hills and mountains. So there are 2-3 types, that is a cabinet solar or the flat solar dryer and the tent solar dryer. Okay. So what kind of products or the agriculture products and foodstuffs can be dry, that is fruits. So grapes and bananas can be dry, vegetables, that is potato, onion, grains, spices like ginger, garlic, chilies, then cash crops like coffee, herbs, flowers, even fish. Okay. So how it is working, the rains are entering in the cabinet through solar collector, okay, and are converted into heat using temperature, or they increase the temperature, okay, and by the heat energy that is transferred in the that cabinet, and that heat energy is useful to be food to be dry. Okay. So this is, we can say, it is a natural process and conventional process. Okay. Now next is a energy which is in the form of wind. Okay. So as the sun heats up, that the earth unevenly, that is winds are forming. Okay. So winds are formed. The kinetic energy in the wind can be used to run wind turbines. As we know, the windmills are, the turbines are rotating. Okay. So the power output is function of the cube of wind speed. So turbines generally require a wind that is range 20 km per hour, and this type or this speed is available only at the hilly region or the at the high altitude. Okay. And the even the wind flow or the speed is constant at that region. So according to global wind energy council, the installed capacity of wind power increased by 25.6% from the end of 2005 to 2006 to total 74% gigawatt, with over the half of the increase in the United States, Germany, India and Spain. Okay. So doubling of the capacity took about 3 to 3.5 years. So now it has not moved, it is increased, the capacity has increased more than this. Okay. So total installed capacity is approximately 3 times that of the actual average power produced, as the nominal capacity represents peak output and actual capacity to generate 25 to 40% of the nominal capacity. Okay. So it has great power potential to generate and gather large amount of energy, that is in 1200 megawatt. Okay. So India is has the fifth largest wind power installation capacity in the world. Okay. And the largest farm is present, it is near Kanyakumari in Tamil Nadu. Okay. So there are offshore wind parks are planned and built over the world. Okay. Now why it is important? It is reducing the, not contributing to greenhouse gas emission. Okay. That means indirectly helping to maintain the biodiversity. So it is important. So it is the wind power energy in water, sorry, so water power energy in water can be harnessed and used in the form of, excuse me, I think it has changed. So this was about wind energy. Okay. That it is uh, free or the easiest source of energy. Our next energy, which is in the form of water, that is hydropower. Okay, so water, okay, or the water power the energy can be harnessed and used from of motive energy or temperature differences. Okay, so that is, since the water is about 1,000 times heavier than air, but even slow flowing stream of water or the moderate seawall can yield a great amount of energy. So there are many forms of water power. Okay, so one is hydroelectric energy, uh, in term usually reserved for hydroelectric dams. The another one is the tidal energy, that power, the tidal power captures energy from the tides in vertical direction. Okay, that means tide comes, water rise a level in the basin, then again tides roll out. So by this movement of water or the tide, the turbines are moving, okay, or they pass the turbine to get out the basin, and this, the, we can say, if the basin is a river delta, then silt will block the turbine. Okay, that is the main issue in the with the tidal energy. So that is a tidal energy uh, stream, it captures stream of water as it pushed back horizontally around the world by tides. The another one is the another form of energy which is present, it is a ocean thermal energy conservation, that is OTEC, uses the temperature difference between the warmer surface of the ocean and the cool or the cold water, okay, or the surface. So that may cause a cyclic heat engine. Okay, so another one is called as a blue energy, is a reserve of a reserve of a desalination, that is a difference in salt concentration exists between seawater and river water. Okay, and this gradient can be utilized to generate electricity by separating positive and negative ions, okay, by ion specific membranes. Okay, so this is a area where the research is ongoing. So but for that the costs are not the issue, but the to pollution or the pollutants which are present in the water, it is the main issue. So the in the Netherlands you can observe the use of this blue energy, that is a salination energy, is used for the generation of energy from the water. So first is a hydropower. So water energy is in the form is the most conventional renewable source of energy. So energy obtained from water flow, that is water is flowing from the height and we are using energy to generate electricity. So hilly and highland areas are suitable for this purpose, where there is a continuous flow of water in large amounts falling from high slopes. Okay. So hydropower is a clean, non-polluting source of energy. It can be transmitted to long distance through wires and cables, but this form of energy cannot be stored for future. Okay. In India, the generation of hydroelectricity has been emphasized right from the beginning of the first 5-year plan, and now the fourth plan, that is by the end of fourth plan, India was able to generate 6.9 thousand megawatt hydroelectricity, that is contributing 42% of total power generation capacity. That means the almost large amount of energy resource, okay, or the energy requirement which is in the form of electricity is fulfilled by water or hydropower. Okay, but as the population is increasing, we are more there is a need or requirement of more energy sources. Okay. So in the western world, although Canada is the largest producer of hydroelectricity in the world, the contribution of large hydro plants has stagnated due to environmental concern. Okay, so though it is producing or fulfilling the requirement, but one of the important thing is that what is the impact on the environment. As we know, to build a hydropower or electricity centers, okay, or the generating centers, we need a large area. So we should take in concern that. So that, but this are does not power does not cause any pollution. It is a renewable. Normally hydropower projects are multi-purpose projects helping in controlling flood, using and irrigation and navigation. Okay, so this is the list of the hydro electricity plants or the projects which are present or in India. So this may come for the examination, that for write down for as an example, or what are the plants which are in India. Okay, so the famous plants are that is Konya, that is Rihand, then Ukai, Balimela. Okay, so and the important one is the Tehri Hydel power project. So it was in the conflict, okay, and built after independence, that is located in Uttarakhand. So ocean, the next type of energy which is in the form of ocean energy, it is called as a or that is ocean thermal energy conservation. Okay, so as we know, ocean are the vast reservoir of water covering about 3/4 of Earth's surface. So this they can be used as a generation of power. Okay, so this may be used in the different form. That is, first is the tidal energy, that the gravitational pull exercised by sun and moon causes tides to develop. Okay, and this tidal energy can be harnessed by constructing a tidal barrage. Okay, so during high tide, the sea water flows into reservoir of the barrage and turns the turbine, which in turn produces electricity by rotating the generators. So during low tide, the sea water stored in the barrage flows out into the sea and again turns the turbines. It provides an inexhaustible, clean and cheap power source. Okay, that means during high tide and low tide also we are getting energy. So total tidal energy potential has been estimated to be about 2 to 10 raised to 10 joules per year. So as we know, India has a big coastline, okay, and it is covered with a, from three side it is covered with the sea. Okay, so this is one of the potential energy source, okay, which we can use. So there are different sites where Gulf of Kutch, Combe, Sundarban, Lakshadweep Island and Andaman Nicobar Island, where the tidal power projects were built and they are generating energy. Okay, so in the picture you can observe that the water stored during high tide, the reservoir that is coming, and they are flowing through a low tide, okay, that is coming and going, and still that is because of the incoming, the turbines are rotating. Same for the low tide, okay, the water is coming or moving from this direction, and then because of force the turbines are moving, and that is used for the electric generation, or sorry, electricity generation. The next form of energy is in the that source of energy, it is a wave energy. So incessant motion of sea surface is the form of wind waves constitutes a source of energy. That means uninterrupted source of energy. So floating propellers placed in a shallow water along the shore may be kept in a state of continuous motion by these waves. Okay, and their kinetic energy can be used to drive turbines to provide cheap, clean, and inexhaustible source of energy to mankind. Okay. So, as we know, as a coastline about 600 km in length, so we can generate estimated that energy which is estimated about or around 60,000 megawatt. Okay. So another form of energy which is in the that source is ocean thermal energy, that is ocean and temperature. So large temperature difference between warm water surface, that is sea water, and cold water, that is 28 degree, the low is or the cold is 28 to 30 degrees Celsius, and the other one is cold deep sea water, that is 5 to 12 degrees Celsius, can be utilized to generate electricity with the help of an ocean thermal energy conservation system, that is OTEC. Okay. So that is floating. The advantage of this uh, power generation or this power is a continuous, renewable, and pollution free. Okay. A floating OTEC, that is ocean thermal energy conservation system, can generate power even at a mid sea and can use to provide power for operations like offshore mining and all. Okay, there is a one more plant which is already present at the Lakshadweep. Okay, so by this process you can observe the turbines are moving. Okay, and that is usually at the ocean. Okay, and the heat is entrapped and that is using to turn the turbines. Okay, the another type of energy is a geothermal energy, that is obtained by trapping the heat of earth itself. Okay, and that is usually far from kilometers deep into the earth crust. So energy harnessed from the hot rocks present inside the earth is called geothermal energy, or energy obtained by trapping the heat of the earth's surface or earth itself. So temperature of earth increases at a rate of 20 to 75 degrees Celsius per kilometer as we move down from the earth's surface. This heat comes from fission of radioactive material occurring naturally in rocks. Okay, so this may be can be used in a three ways. Okay, one is for geothermal electricity, there is geothermal heating, that is through deep earth pipes, and the another one is geothermal heating, that is through heat pumps. Okay, so this heat comes from the fusion of radioactive material occurring in the rocks. Okay, artificial drilling a hole to the hot rocks, putting a pipe in it makes the stream of hot water gush out through pipe at a high pressure, which turns the turbines of generator to produce electricity. Okay, so this is a clean, cheap, and free pollution free source which is available in the nature. Okay, so it is used in New Zealand, Ireland, Italy, and USA. Okay, so in the Ladakh there is one more the plant is there, that is in the Puga and other area where Tattapani, that is Sarguja district in the UP, Combe Basin, that is Alaknanda Valley in UP, and Parvati Valley, that is in the Himachal Pradesh. Okay, so by the temperature, okay, the heat is generated and that is converted into the electricity, that is a geothermal energy. Okay, see the heat exchanger with the working fluid and turbines are rotating and that is generating energy. Okay, now another one is or the alternative source of energy are biomass energy, okay, petro-crops, biogas energy, okay, alcoholic energy, hydrogen as a fuel, okay. So that we'll see in the next lecture. Okay, now we can cover it in this lecture only. So there are alternate source of energy. These are present in the form of biomass energy. That means the material which is present on the earth for the production of energy. Okay, that means organic material which is present on the energy. Okay, so first one is that is the conventional sources, like why we are turned towards the use of this conventional the alternate energy sources is to reduce the utilization of non renewable energy sources, okay, and to reduce the pollution. So first thing is the biomass energy, that is a biomass through burning has been used as a energy source even by prehistoric man, okay, that is the fuel or the different plants which are used for the energy, okay, or the biogas like this. So biomass is the present time has been converted into suitable and convenient state before it can be used. Some of the important energy sources which originate basically from the photosynthetic activity of green plants. Okay. First, which is in the form of it is used, it is a dendrothermal energy or energy plantation. So energy plantation is the plantation of fast growing plants like cottonwood, poplar, leucaena, herbaceous gland, sugar cane, sweet sorghum, sugar beet, water hyacinth, seaweed, that is carbon rich potato, on denuded wasteland, which may provide energy either by burning directly or by getting converted into burnable gas, may be converted into fuel by fermentation. Okay. That means high hydrocarbon or the hydrocarbon rich plants or organic material is used to form gas or fuel. Okay, that's these are the dendrothermal energy. So there is a dendro power project. It is in the Sri Lanka, okay, and it is supported by China, where the plants are grown, okay, and that is used for the dendro power project. Now what are the next biomass energy which is available in the form of petro-crops? So the hydrocarbons present in some plants can be converted into petroleum hydrocarbons under high temperature and pressure, which may turn in diesel engines directly or may be refined to some gasoline. Okay, so that means plants, okay, can be converted into petroleum hydrocarbons by some processes, okay, and that may can help to turn or run diesel engines, okay. So a number of plants belonging to family Euphorbiaceae and Asclepiadaceae, that is Apocynaceae, Convolvulaceae, that is Convolvulaceae, that is possesses this hydrocarbon in the sap and latex, okay. So 15th species are found promising. The that the Indian Institutes of Petroleum, Dehradun, has done excellent work in this. So the products obtained from their latex process crude were gases, naphtha, kerosene, gas oil, heavier, and coke. That means the common plant or the example which you have studied is jatropha. Okay, that means if you cut that plant, then latex or the white color portion which may come out. Okay, so maybe sap or latex. Okay, that is used to produce energy. Okay, it is in the form of gases, oil, or coke, kerosene. So it is one of the good source of energy or the alternate source of energy. So the another one is energy from agriculture and urban waste. Okay, so with the application of proper techniques, urban waste, crop residues, biogas, coconut shell, peanut hulls, that's cotton stalks, etc., can be used for the production of energy. A pilot plant for demonstration has already been set up in Delhi to treat solid municipal waste for conversion into energy. Okay, so that produce nearly there is 4 millions that is sorry 4 megawatt energy per year. Okay, so that's a bagasse, a waste of sugar. Okay, sugar mill can be used to generate energy. So it is estimated that sugar mill in India can generate 2000 megawatts surplus energy during the crushing season. Okay, so in the Brazil there is a 30% of electricity is obtained by burning bagasse, that is a waste product of the sugar cane. So like bagasse, other farm waste such as rice husk are also being used to produce energy in the form of electricity. Another alternate energy source is biogas energy. Okay, that is many organic materials can be released gases. So due to metabolization of organic matter by bacteria, that is anaerobic digestion, or by fermentation. Okay, so landfills actually need to vent this gas, that is landfill gas, to prevent dangerous explosion. Okay, so what can be used? Most probably the organic matter, that is maybe the animal feces or the that is leftover food or the vegetables. Okay, can be used in biogas, and that releases methane under the influence of anaerobic bacteria. Okay, so under high pressure, high temperature, and anaerobic condition, that even the wood may be converted into a gaseous product. Okay, so this is often found more difficult than the direct burn, more efficient than the direct burning, because if by burning the carbon emission is very high. So instead of that, the conversion in the biogas, that is to convert into another form, it is good for the environment. The gas can be used to generate electricity or heat. Okay, so biogas can easily be produced from current wastewater streams such as paper production, sugar production, sewage, animal waste, and so forth. The various waste streams have to be slurried together and allowed to naturally ferment and producing methane gas. Okay, so this can be done by converting sewage plants into biogas plants. When a biogas plant has extracted all the methane, it can then the remains are something better suitable as fertilizer than the original biomass. Okay, so the leftover or the what we can say the leftover product, that is after gas production, it is rich in organic matter and along with the bacteria, so that can be used in the farm as a fertilizer. Okay, so biogas is non polluting, clean, low cost fuel that is very useful for the rural areas where a lot of animal waste and agricultural waste is available. So India has the largest cattle pollution population in the world, so we can use or we can rely on the biogas production. Okay, that is a gobar gas plant. So you can observe inlet pipe, that is dung plus water, mixing tank, then the the bacteria digest whatever the material is present, and from another outlet pipe that the gas is coming, and then it is developed or they pass through a different pipe or the outlet. So another is a fixed dome type. So this one is a floating gas type, okay, because the gas is coming over here. The next one is fixed dome. Okay, so the slurry is passed through this chamber or this inlet chamber, then this is the outlet chamber. Okay, and by these pipes, okay, or these outlets, the biogas is collected from this outlet. Okay, so this is a overflow tank. Okay, and the dome is fixed, as you can see the size, the dome is fixed, that is underground. See, so only what portion you can observe is this one, the dome portion. Now another form of energy is alcoholic energy. Okay, so ethanol, methanol can be produced through an anaerobic fermentation of plant material containing high sugar proportions. So ethanol can directly be used in automobiles after slight modification of the engines. So gasohol is a mixture of ethanol and gasoline. Okay, so that is nothing but ethanol and petrol. Okay, is a common fuel in Brazil and Zimbabwe for running cars and buses. Okay, in India too, gasohol is used as a trial basis in some part of the country. That is the ethanol, that is we are trying to more increase the percentage of ethanol, so it may cause a less pollution. Okay, and it is cheap as compared to the other sources. Okay, so that is petroleum. So methanol is an advantageous automobile fuel as it burns at a lower temperature than the petroleum and diesel. Okay, so the use of methanol may thus help in eliminating bulky and heavy radiators. Another source of energy which is in the form of a hydrogen, that is hydrogen burns in the air, it combines with oxygen to form water, and a large amount of energy, that is 150 kilojoules per gram, can be formed. So due to high calorific value, hydrogen can be served as an excellent fuel. So moreover, it is non-polluting and can be easily produced. So production of hydrogen is possible by thermal dissociation, photolysis and electrolysis of water. So as we know, thermal dissociation by heating, photolysis by radiation, or electrolysis of water. Okay, so that we can separate the hydrogen by thermal dissociation of water, that is hydrogen is produced. Okay, thermomechanically, hydrogen is produced by chemical reaction of water with some other chemicals in 2 to 3 cycles, so that we do not need the high temperature as in the direct thermal method, and ultimately hydrogen is produced. So as we know, it is produced the pure form of hydrogen, which we can produce only by the chemical reactions. Okay, so that we need a high temperature, but electrolytic method associated water into hydrogen and oxygen by making current flow through it. Okay, and the photolysis involves breakdown of water in the presence of sunlight to release hydrogen. Even the photolysis of water takes place in the plants also, that is in the non-cyclic the cyclic reaction, that is oxygen evolving complex, that where the photolysis or the process actually takes place. Okay, the green plants also have photolysis of water during photosynthesis. So efforts are underway to trap hydrogen molecule which is produced during photosynthesis. Okay, but as we know, hydrogen is highly inflammable and explosive in nature. So we need, hence safe handling is required for using hydrogen as a fuel. Also, it is difficult to store and transport, and being very light, it would have been stored in a bulk, but presently hydrogen used in the form of liquid as a fuel in the spaceships. Okay, so why you need, there is a need of alternative energy sources, that is as the population is growing, we need to fulfill the need of energy sources. Along with that, we have to search a source which is causing less pollution, it is easily available, cheap as compared to other products. Okay, and it should not exploit nature in a great extent as we see in the non-renewable energy sources, and it should fulfill the even small needs like transport, traveling, lighting, heating, all these things. Okay, and the investment should be less. For that we need alternative energy sources. Okay, so here are the some resources. Okay, that is the, sorry, not resources, sources which I have used for this chapter, that is chapter number 3. Okay, that is natural resources. So till now we have completed all the, that is chapter, that is land resources, deforestation, water and energy resources.